uh, over here we can provide glycerin over here in the gas filled temperature gauge. Okay, so this gas filled temperature gauge having fast response time over the bimetallic gauge, and it also shows the high reliability. So guys, that's all for our today's video. So guys, in this video we have seen the specifications and the construction of the gas filled temperature gauge. So guys, I hope you like our video. So if you have liked our video, please hit like. If you have any doubts and any queries, please do comment below. And guys, don't forget to share all my videos, engineering related videos, to your friends on our social networks. So guys, thank you so much for watching my video. Please subscribe to my educational channel, Engineers Academy. Thank you so much.
Hi, I'm Josh Bloom. Welcome to another video on the RSP Supply Education Series. If you find that these videos are helpful to you, it certainly helps us out if you could give us a big thumbs up and subscribe to our channel. In today's video, we are going to talk about a device that is used commonly in industrial applications for collecting temperature data. I am not talking about a thermistor or thermocouple. I am talking about a resistance temperature detector, or sometimes commonly referred to as an RTD. An RTD is a type of input signal commonly found in industrial monitoring situations. The same types of situations where you might find basic digital and analog signals coming into a PLC. Much like those digital and analog signals, depending on the PLC hardware that is being used, you can also input RTD signals into the PLC accurately to read temperature data in many different applications. In this video, we will talk about what hardware makes up the RTD and how it works. We will also discuss some of the reasons RTDs are used instead of other temperature devices such as thermocouples or thermistors. At its core, RTDs use a specific type of metal that, depending on the resistance measured in that metal, can determine the temperature. The actual measurement occurs at the element, which is a portion of the device that actually is able to collect the data needed to provide accurate temperature readings. There are many different types of RTDs, some more common than others. A few examples are: first, the thin film element, which uses a very thin layer of resistive metals adhered to a substrate, typically ceramic, then coated in glass or epoxy. Next is the wire wound element. This type of element can provide greater accuracy and wider temperature measurement ranges, however, can create stress on the element wire, which can lead to slight measurement errors over time. Lastly is the coiled element, quickly becoming the most common type of RTD element. The coil element combines ideas from the two previous types as well as additional design elements. This element allows for strain-free measurement on the element wire while still providing very accurate measurements. So how do these different RTD elements actually work? RTDs work off a very basic principle, which is the correlation between metal and temperature. As the temperature of the metal increases, the metal's resistance to allow flow of electricity increases. So it stands to reason that as the temperature of the RTD resistive element increases, the electrical resistance measured in ohms also increases. Understanding this resistance and its relationship with heat is what can give us an accurate temperature reading. Each metal has a certain resistance measurement at different temperatures. So based off the resistance that is measured in a given type of metal, we can determine what the temperature actually is. The most common types of metals used in RTDs are platinum, nickel, or copper. So what are some of the advantages of using RTDs as opposed to other types of temperature measurement devices? First and foremost is the high level of accuracy they can provide. They also provide a very wide operating range, which can make them a great option in many different applications. Also, because of their high accuracy level, they are often used in situations where temperature measurement is critical. A few disadvantages include the fact that RTDs are rarely used at temperatures above 660 degrees Celsius. Above this temperature, it can become difficult to prevent the metal from becoming contaminated by the metal sheath surrounding the RTD element. Also, at lower temperatures, RTDs do not provide the same level of accuracy or resolution as thermistors, which is another type of temperature measurement device. As you can see, for the most part, RTDs offer a great option for many different temperature measurement scenarios. Because of their reliability, high level of accuracy, and ability to measure a very wide range of temperatures, they are one of the most widely used temperature measurement devices today. For a full line of RTDs and thousands of other products, please go to our website. For more information or other educational videos, go to rspsupply.com, the internet's top source for industrial hardware. Also, don't forget, like and subscribe. Hi, I'm Josh Bloom. Welcome to another video in the RSP Supply Education Series. If you find that these videos are helpful to you, it certainly helps us out if you could give us a big thumbs up and subscribe to our channel. In today's video, we are going to talk more about specialty sensors designed to measure temperature. In one of our other videos, we talked about a similar device called an RTD. However, today we are talking about thermocouples. Much like an RTD, thermocouples are used in a wide variety of commercial, residential, and industrial applications. Thermocouples, much like an RTD, are designed to accurately measure temperature, but the way they go about achieving that measurement is very different. In today's video, we will talk about the hardware that makes up the thermocouple. We will also talk about how they actually work and in what applications it makes sense to use a thermocouple as opposed to other temperature measurement devices. So what makes up a thermocouple? Simply put, a thermocouple consists of two dissimilar metals. These two different metals are welded together at one end, creating a junction between them. It is at this point where the temperature can actually be measured. To protect the two different metal conductors, it is common to see this measurement end of the thermocouple housed in some sort of protective sheathing, commonly stainless steel, but other materials can be used as well. The two types of metal used with the thermocouple can vary depending on the type of thermocouple that is purchased. Type K thermocouples are one of the most common, and they use a combination of nickel chromium and nickel aluminum. But again, depending on the type of thermocouple, those combinations can vary greatly. So how does the thermocouple actually work? Well, it's really quite simple, which is one of the reasons it can be such a reliable method for measuring temperature. When the two conjoined metal types experience any kind of temperature change, there is a very specific voltage that is created. Based off of the amount of voltage that is created, you can determine the temperature very accurately. Thermocouple voltage reference tables can be used to find out the temperature ranges based off of the type of thermocouple being used and the voltage that is being created. So why would you use a thermocouple as opposed to an RTD or other temperature measuring devices? There are a few main factors that make thermocouples very good options in certain situations. First and foremost is cost. The average thermocouple can cost about 2 to 3 times less than the average RTD. So that alone makes them a better option for many people. Also, depending on the type of thermocouple that is being used, they can have a higher temperature measurement range than RTDs. For example, noble metal thermocouples can measure temperatures as high as 3,100 degrees Fahrenheit. Another strong reason why you might use thermocouples is the fact that in general, they are considered more durable overall than RTDs or other measurement devices. With all the advantages they can offer, there are a few disadvantages. First, they are not considered to be as accurate in temperature measurements as RTDs. Also, in many lower temperature scenarios, RTDs can provide better resolution, giving the user a more accurate measurement. As you can see, there are many different applications where using a thermocouple is a great option. With their relatively low cost and high level of reliability, they make a great option wherever temperature measurements are important. For a full line of thermocouples and thousands of other products, please go to our website. For more information or other educational videos, go to rspsupply.com, the internet's top source for industrial hardware. Also, don't forget, like and subscribe.